Hello again all. I'm going to really try and make an effort on a few more updates this year. So with that in mind, completed a few tasks that I've been putting off for a year or two in some cases. So first of all, having done the DRO install, the other job I wanted to do was to install the VFD controls. So this is a very similar layout to the one on the L5, but with a rather nice die-cast enclosure that I had forgotten I had. This took quite a lot of work and resulted in me being out of action for a few days. The inverter on the L5 is in this left hand side of the cabinet because the motor is mounted behind the cabinet, whereas on the L6 it's mounted inside the cabinet on this hinge down door arrangement, which makes it very easy to service the motor, providing you haven't got a tool cabinet immediately behind it. But it means there is no room in this end of the cabinet to fit the inverter. So the inverter is fitted down this end of the cabinet. You can see a few screw heads sticking out. Now this is where the sump for the coolant system would normally be. Now I don't run flood coolant, and if I did I'd probably run an external tank just for ease of cleaning. So quite a long time ago I put the inverter in there and wired it up to the start and stop buttons that were on the panel, which is now blank, and there was a cable running through the inside of the storage cabinet that was the power for the pump. So there were holes there, and I just ran the output from the inverter and the control cable through there. In fact, I think I might have reused the pump power cable as the control cable to the on-off buttons. I used the buttons that were attached to the original motor starter, so just tapped into the contacts on the starter. And in fact this whole job started when I was just looking at doing this upgrade, and I slipped with the panel and managed to smash the motor starter to smithereens, because it's all Bakelite, and ended up having to start this job. And I've kept the control wiring separate from the power wiring, and had to get inside the cabinet and drill some holes to put a piece of 20mm conduit in, which runs just up in here. My tips of my fingers are touching it, so it's completely out the way. And I don't know if the lighting will cooperate, but yeah, there's also another bit of 20mm conduit at the back there where the original pump wiring ran through, just to tidy things up. So that's got the 3-phase cable to the motor. The control wiring runs at the top front here, and my right angle air drill earned its purchase price, being able to put those holes in. But that job involved me doing a reasonable amount of kneeling, and having dislocated my left kneecap a number of years ago, it will sometimes object to me doing things like kneeling, even though I was using kneeling pads, and I ended up with my left knee twice the size of my right, and barely able to get up and down stairs. It's still twinging now, but we are getting on with stuff. I reused the original isolator and the mains wirings coming in through the conduit adapter as it did originally, And the control box I've done slightly differently to the other machine. So you've got jog, motor stop, forward, reverse. But the speed control is a switch. What I've discovered from the other machine, where that top left control is a potentiometer, is I virtually never use it. I just leave it set all the time. Now that L5 was a relatively small motor version with a top speed of 750 RPM, which actually matches the top speed here at 750. The 1500 is with a higher motor speed. This particular machine having been factory fitted with a 2-speed motor. So on the L5 I gain those high speeds by running the motor frequency up. In fact, I can run it up to 120 Hertz and get a really decent high-end spindle speed, which I rarely actually use, and that's the only time I really turn it up. And very occasionally, if I'm getting a little bit of chatter, I can tune it out by tuning the spindle speed. But what I decided to do on this machine, and a little aside, the 2-speed motor, which it changes the 2 speeds by switching between 2-pole and 4-pole winding configurations, cannot be rewired for 240 volt. I had a motor which also couldn't be rewired for 240 volt. It was a star delta motor, but it was 720 volt in star for star delta starting, but it was also a 5 horsepower motor, and in fact you can run a 415 volt motor on 230 volt, but the torque will drop in proportion to the voltage change, which means that a 5 horsepower motor for 415 volt is a 3 horsepower motor on 240, and that's what this machine had originally. So that's how I've made this machine work. And then I puzzled through the VFD control book and worked out that if you put it into PLC control mode, you can use some of the inputs to switch between fixed speeds. So now it has a 25 Hertz running frequency and a 50 Hertz running frequency, duplicating the original 2-speed motor setup. And the last job I've got to do on here really is just put an indicator LED on there to show me the VFD's powered, though part of the plan on both lathes is to fit these LED battens above the machines for improved machine lighting. So, having got that VFD job out the way, there was another one, and this machine has been running on a Eurotherm drive, and take it from me, the Eurotherm programming is much worse than the Chinese VFDs I have in the other machines. Much more confusing manual, even though it's nominally in better English. It actually explains things worse. But I just had this box on this face of the machine with the buttons pointing this way, and I was used to it, but it's by no means as convenient as having them right in front of you in your eye line for start-stop. And also, I was powering the machine on at the wall socket using the switched outlet, which sometimes meant I forgot and left it on. So I have now fitted a no volt release switch into the cabinet to power the VFD. So that was another job that finally got done. That didn't take too long. You know, I drilled and tapped a lot of holes to put the wiring in. Cut the hole in the cabinet. And then there's a little setup I've got on the mill there, just checking the port spacing on these throttle bodies. And into the utter chaos of the main workshop. And I was going through my cylindrical grinder, which is a really nice fully hydraulic automated machine that came from the rocket propulsion establishment at Westcott. Has a Royal Ordnance tag and a an OHMS tag on some of the parts. When I bought this, I thought I'd be using it a lot, but the thing I wanted to use it, I was going to use it for, it only got used a handful of times. It's mostly been sitting, and I've just been going back through the control system, checking everything out. Discovered that one of the contactors was bad. I was having a bit of a trouble getting one of the functions to work, and it seemed to be intermittent, and the next thing I could smell hot plastic, and it turned out that one of the contactors had got a high resistance contact in there. It was actually one on the main power input. So spent a bit of time with this, found out what the problem is. I just haven't actually put it back together. And when I bought the cylindrical grinder, I got a really good deal on this Eagle surface grinder, and this is a really basic surface grinder. It's not a high precision machine, but it gets the job done most of the time, and it's been used occasionally, but it was only ever kind of lashed up to a VFD when I actually wanted to use it. And this was using one of my two original Siemens Semovert inverters, which were 90s technology, 4 times the size of a modern unit. And I just passed those 2 units on cheaply to somebody who's just acquired a Bridgeport style mill, got them up and running on single phase. But I decided it was high time I actually got this machine permanently wired to an inverter so that it can be used whenever I want to. Now the problem with a VFD is, where do you put it? I know a lot of people put them in wall mounted boxes, but I like to have them on the machines. And whereas I'm quite happy for my linisher to have its VFD strapped to the mounting arrangement, which is from a dead pillar drill, because that is a really cheap and nasty VFD. I've had a good experience over the years with the Huanyang VFDs, and when I needed another one, I bought this one, and it turned out this isn't a Huanyang, it's a copy of a Huanyang, and it's an Ask Power. And rather than having, 120 odd parameters you can set up, this has 35. And some of the basic ones that you'd really like are missing. So I'm not really concerned if this dies, because I'll just replace it with a better unit. But it's been fine. It doesn't get too much of the dust on the back there, and this one is just set up to automatically start the motor on power up. So I do at the moment just operate this from the wall switch. It'll probably get a little control box, because I do use the linear more and more. I'm in the process of fixing the worn out table. Sorry for the slightly chaotic presentation here. I just decided to grab the camera at short notice, but that's the cast iron table from the Vanco, and it is very worn in the centre there. So I have got a bit of 1/2 inch plate that I'm going to bolt to it to make a new table surface. I did many years ago. You can see that the platinum's got 2 sets of mounting ears, and that's because I simply turned it round. See, there's a huge dip where the belt wore it, but I just turned that piece round, welded a new mounting ear on, because this is actually this isn't mild steel. This is some gauge plate or something. It's a little bit tougher. That's just waiting for me to get the table back on it. So where were we? Yes, back to the Eagle. Decided I'm going to mount the VFD, and that's the VFD on the floor there, and that's the same rating as the one on the Linear, but is 2/3 the size or less. And I decided I'm going to make a little cavity on the front of the machine to put drop a little folded steel box in to put the inverter in, so that I can get to it from the front. The motor's at the back on here, and although there's room to squeeze the VFD in there, it would be close to the belt, not in terms of clearance, but in terms of any belt debris getting shed over the years. So having it at the front and having a little bit of a box, but I decided to cut an access hole through the base casting, and this machine has always been a pig to move around. The base is not flat. It's remarkably heavy for its size, and there is the piece of cast iron I've managed to get out, and this took all in all 3 days, mainly because of the amount of time I'm prepared to spend crouching down, stressing my knee, but also how tired my arms were getting doing the drilling. And I went through a lot of cobalt drills getting through this. The iron is really inconsistent. It's got a hard skin, harder than you'd normally expect, and quite a lot of really hard spots. There were holes that just wiped out a drill bit almost instantly. I ended up having to drill everything 3.2mm. Why 3.2? Well, that's what there were a lot of in the drill bit set. Then I went out to like a 6, and then an 8, and then finally up to a 10. And even so, there were spots that just wouldn't drill, and it got to the point where I managed to break through some places with a cold chisel, get it weak enough that I could just smash it out with a hammer. And the next job is to create a little safe area, put some cloths down, maybe a bit of polythene to control the dust, get the vacuum cleaner in, get my airfoil hooked up, clean up the edges of this hole, and then we can get the VFD in there and put a control box on the top. This did originally have a motor starter mounted on a box on the top casing, and the other job, which is a remarkably long-term one, was putting the mag chuck back together. I bought a replacement mag chuck, which is this close pole one here, but sometimes the big, it doesn't grip anywhere near as well as this one. It's obviously much better for small parts. This thing, when I got the machine, could only be operated with the mallet. It was so tight, and I ended up taking it apart, and although people say you can't take them apart, you lose the magnetism, well, that's true of Alnico magnets, which I think this is, but it's only true if you completely break the magnetic path. So I always left the magnets on the bottom plate, and I only removed the top plate and the spacer. And the issue was actually with this top plate. These pole pieces are fitted into the top plate with an epoxy resin, and I think over the years the coolant that had been used had caused the resin to swell, and on the underside of this plate it was sticking down, and it was causing the magnet to bind and be incredibly hard to remove. So I'd taken the top plate off, scraped the resin and stoned the underside of the plate, and then it had just sat, and it has been down in the tray of the machine for years, collecting swarf, as magnets are wont to do. But I got this all cleaned up, put it back together, and I can't say it's easy to operate the magnet, but it is now possible to do so by hand, and it seems to have really good clamping force. And when the machine's up and running, I'll obviously get it all ground in and working well. So that's the current state of the chaos. I've got some more bends in for doing the manifold on the Busso. I've got to go and collect a gearbox. That's hopefully happening this next week, and a little bit more progress might get made. So that's all for now, until next time.